Okay, I like to call this problem the bargain problem because basically you get to do two at once. So this is going to take up quite a bit of space. I may have to even take this over to the next page. I'm not quite sure yet, so just be ready for that. This problem just takes up quite a bit of space, but it's a bargain. It's basically you get to solve two problems in one, so that's exciting. So the same concept applies. First step is to isolate the radical. So I'm going to add the square root of x plus 1 to both sides. Now here's the deal on this one. I'm now left with the square root of 2x plus 3 is equal to 1 plus the square root of x plus 1. And that extra 1 outside of the radical, that's what makes this problem a bargain. So now, whenever I look at this, yes, we are going to square both sides because it's a square root, but when you square that right side, so you have a 2x plus 3 here on the left. When you square that right side, that is now a binomial. So you're going to have to multiply that out. So you have 1 plus the square root of x plus 1 times 1 plus the square root of x plus 1. So you have 1 times 1 plus 1 square roots of x plus 1 plus 1 square roots of x plus 1. And then when you square root x plus 1 and you multiply it by itself, you square that. Because all you're doing here with this problem is you're going to FOIL. So now combine your like terms. So on the left I have this 2x plus 1 still. Pardon me, 2x plus 3, and then 1 plus, there are 2 of these, so remember when you're adding radicals, you add the coefficients if it's exactly the same. Then the square and the square root cancel out, and you're still left with an x plus 1 over there. And here is the bargain. This little guy right here. The fact that you still have a radical in your problem, you go back through the process again. Isolate the radical, and then square both sides. See, it's a bargain, like a 2-for-1 deal. You are welcome. So, let's do it right now. I have this 2x plus 3 still on the left, but I'm going to combine my like terms. There's a 1 and there's a 1. So I'm going to put this x in front. It's the same x that I already had, plus 2 from this 1 and 1, and then plus those 2 square roots of x plus 1. Now I'm going to subtract the x and subtract the 2 so that it can get all on the same side. Those cancel, and now I have an x plus 1 is equal to 2 square roots of x plus 1. Now, when you isolate the radical, as long as it's that single term, you're in good shape. You don't have to divide by 2. And if you did try to divide by 2, you'd end up with a bunch of fractions on the left-hand side. No one wants that. So, with that being the case, we are going to square both sides now. And we have a binomial on the left, so you FOIL that out. I'm going to do the shortcut FOIL method, where you square the first term, multiply the 2 terms together, the x and the 1, and multiply that by 2, and square the last term, is equal to, now when you square a single term, like this is still considered a single term, you square each piece. So 2 squared is 4, then the square and the square root cancel out, and I'm just left with the x plus 1. All right, now you have your quadratic again, set it equal to 0. So x squared plus 2x plus 1 is equal to a 4x plus 4. Subtract that. And I'm actually gonna move up to our next side over here since I'm out of room, and we'll see how it goes. So I'm going to change my color over here to green by moving it up here to the top. So I now have the x squared still. And 2x minus 4x is a negative 2x minus 3 equals 0. And now you get to factor. That should make you happy. Doing all this work and then we get to factor at the end. That's awesome. So I end up with x equals 3 and x is equal to a negative 1. Are we finished? No. What do we still get to do? Yes, we get the amazing opportunity to check this now. So let's plug it in. I have, for x is equal to 3, I now have the square root of 2 times 3 plus 3 minus the square root of 3 plus 1 equals 1, and then simplify that. So this actually ends up being the square root of 9 minus the square root of 4. So 3 minus 2 is 1. So 1 equals 1. We know 3 is a legit answer. Whoo-wee. That's awesome, right? Now, let's check 1. So I get the square root of 2 times 1 plus 3 minus the square root of, negative 1. I meant negative 1, sorry about that. 2 times negative 1 plus 3 minus the square root of negative 1 plus 1 equals 1. So this is the square root of 1 minus negative 1 plus 1 is 0 equals 1. So 1 equals 1. That is also a viable option. So for this problem, you don't always get both answers, but in this instance, we do have both answers. Awesome. Great job. It was a bargain. It took some space, but it was worth the effort.